Alright, so this is a test to see whether or not this is actually going to work. We're going to start talking about science today. This is our first lesson, lesson 1.1. It's all about the basic organization of the universe. So now I want you to look up here and think about how everything in science is based on perspective. What angle we're viewing things from and what angle we're going to continue looking at it towards. If we look at the universe from the inside out, there's two models that the ancient Greeks proposed. The first was the geocentric model. That put the Earth in the middle. G for globe, G for the Earth. The Earth was in the middle with circular orbits of everything else around them. Now, alternatively, the Greeks also suggested a heliocentric model. Helios was the god of the sun. He is helium, which is the fuel for the sun. Sun-centered, centric-centered. The sun would be in the middle and everything else orbiting around it. Now, again, that's two models. The geocentric with the globe in the middle and the heliocentric with the sun in the middle. However, if we look at how it's organized, we also have to look at the history and how it got to be where it is. That's where the Big Bang Theory comes in, just like the show. So the Big Bang Theory is the most accepted idea of how the universe came to be. Now what that means is that we started with a central point, and an explosion occurred which caused the formation of the planets from heat, compression, and the movement and collision of particles like rocks, pebbles, dust, sand, gas, and everything in between. Now if we fast forward a second and look, the Big Bang Theory, or the creation of our solar system, can be broken down into four main steps. So, the formation of cloud and dust in the universe, the explosion that provided us heat, as well as force for compression, and then the sun and planets formed from that. So if you imagine all these different things moving around in space, they're going to hit each other and stick and become something bigger. When they become something bigger, it's going to lead to them forming planets. And in the sun, the heat allowed for the trapping of all those compounds that stay together in a sun to ignite with helium, again back to Helios, and create the constant fire that we see today. Now, if we go backwards from our solar system and want to look at everything in the universe, we have to take a glance at what else is there. Of course, as we know, living on Earth, there's planets, and the solar system is made up of a collection of planets. Now, move forward even further. A galaxy is made up of a collection of solar systems, and all of the galaxies together with all of these pieces, that creates a universe. So our universe is a collection of a variety of different pieces. That's something that we're going to explore a lot in this class. Small pieces that lead to bigger pieces that affect smaller pieces. Now what's really important to note is that within our solar system, the Milky Way galaxy, we have our 8 planets and our main star. Most important about all of that is that, of course, the sun is in the center, as we all know, heliocentric model, but there are 4 inner planets and 4 outer planets. The 4 inner planets have a tendency to be hard, rocky, and dense. Does anyone know which planet we are? We are the third rock from the sun, like the show. It goes Mercury, Venus, Earth, Mars. All of them are going to be hard, dense, rocky planets. When we move past Mars into the outer planets, we see that we have Jupiter, Saturn, Uranus, and Neptune. Those planets are going to tend to have a higher concentration of gas in their atmosphere and going to be more loosely packed than those are the closer they are to the sun. Now, for later this week, we're going to explore why that idea might be through a concept that you know very well. Some of you might be raising your eyebrows and thinking, well, what happened to Pluto? Pluto would be way further out on this spectrum, so past Neptune, way past Mars, and way past the sun. And Pluto was tiny compared to the rest of the planets. So we had to learn that Pluto, because of how far it was from the sun, because of how small it was, is actually considered a dwarf planet, not considered a full-fledged planet. Now, moving back and forth in this scale that we have, universe all the way down to planets, we're going to go up to and go to galaxies. There are a few types of galaxies, as you can see over in the corner here from my illustrations, one of which is going to be the spiral galaxy. That is the one that we live in now, the Milky Way galaxy, where you constantly see a circular rotation moving things out. The other is the barred spiral, which is similar to what we live in, but it only has 2 pieces churning in each direction instead of multiple pieces going multiple ways at the same time. The next, which you've probably seen pictures of, is the elliptical galaxy, and that's going to have constant rings. Now the last is the irregular, and it is all over the place. That means there's something here, something there, and something everywhere in between. Now one important concept that we need to note that affects us still today is not just all of this organization, but it's how we think the Big Bang happened, how we see it still in practice. Now, I mentioned that is the Doppler effect, and we see this every day. If I get closer to the camera and I speak at the same volume, my voice gets louder. If I scoot away and speak the same volume, it seems like it gets quieter. Much like an ambulance coming towards you on the road or going away from you on the road, you experience the lights and sounds in a different way. So the Doppler effect states that as a wave, so a light or a sound, gets further away from us, so this is me, nerdy science guy. As it gets further away from us, these waves spread out. You see the bands are spread out. That means that sounds will get quieter, which we've all experienced, and lights will also get dimmer. Now, the opposite is also true. As the waves get closer to us, they get closer to us, the light, the sound. We'll notice that the lights will get much brighter, and the sounds will get much louder. Now for today, that's all we have. Study these terms, look at what else is online, and for those of you that are copying the notes, you won't even see this.